Welcome again to Grasshopper for Rhino, the 1, 2, 3 ABCs of it. We're going to be going into probably, I think, one of the best tabs to get to know and use, especially if you're building sculpture, if you're making something architectural, if you got to engineer something. It's to get a hold of the vector tab in the vector menu and understand everything from deconstructing a vector all the way through to making it. So we're just going to jump into it. It's not very exciting, but if you can wrap your head around the simple concepts of where to begin, keep in mind vectors aren't really visible. You've got to make them visible through the display tool. You've got to go in and you have to see vector display or use vector display EX. Let's jump into it and see what we have. We'll put this on so we can only see what we're clicking. And it's not going to be too exciting, like I said, but we're going to take our perspective view, go to shaded, and see what pops in here as data. Basically constructing a point when we go into here, back to the vector tab. We've gotten into that through the point tools. These are obviously essential as well, but the vector tab, you create a point, and what can you do with it? Once that's there, you can see that vector is this one. And actually, I better stay with it. I've got my wires going pretty wild. So let's start with that point. We're going to take this vector, which is constructing a vector, x, y, z. I've just brought in a number slider that I can actually visualize it that way. So basically, in that direction, I've got a vector that'll change its magnitude. It's got direction and magnitude, and that's it. And so you need to visualize that. So it's from an XYZ component. I'm going to be using this point again and again and again, so I just brought in a point to be the 0, 0, 0 point that I'll be using, and that's why that's just feeding in for the anchor for most of these vector displays, if not all of them. The amplitude is a way to multiply that, so that vector display we have to go on and we have to see, once again, deconstructing that vector. I'm going to have to grab a visualization, keeping to the point, show you that vector, and I have control over that amplitude that I can multiply that vector and start to change the shape of it. And that's it. You're going to be using this all the time. Deconstructing the vector takes that vector and brings you back to the X, Y, and Z component. You can see, you can pull out the data for each one. They're all the same because I've multiplied with them, and they've all, unless I change this number slider and plug it into another number in the Y-axis, say, then you can pull out your Y and see that it differs from the other two. So there's your X and your Y and your Z. Just getting the sense, once again, of using your panels and using, once again, what I've said time and again, your param viewer to know what your data looks like on its indices, branches, and paths. Okay, then we're going to just go into here and make a unit vector, which is kind of cool. And I've grabbed a basic vector, and you're like, well, what's that do? So let's grab that one. What does the basic X vector look like? Well, it looks like that. And what's the basic Y vector look like? It looks like that. And what does the basic Z vector look like? It looks like that. So in grabbing a unit vector out of all of it, a visual display, you're going to be grabbing all three of them. The unit vector is kind of cool because it's going to make everything 1, 1, and 1. Kind of reparametizing, in a sense, what you're doing. Here's a plane. I've got an angle plane. So if I grab that plane and I want to start playing with the vectors to control which angle that goes, it's going to default to 90 degrees because these are the X, Y, and Z vectors. But if you change them, you're going to get a different radian coming out of here. Not going to get into the reflex right now. So rotate those vectors. You still need a visual display. And right here, I've got hooked to radians and pi. You can see that I can actually change that vector. And that's a rotation all the way up in the Z, all the way underneath, and then back to the the Y-axis again. So that's actually pointed if I rotate this. There, get it situated. Oh, where'd it go? Come on, over here. So you can see it's in the Y direction, and I'm rotating that up and over and all the way back to the Y for 2 pi rotation. And we're visualizing that. So let's go back into here. I've got a unit vector here. Cross product's pretty interesting if we visualize what that's doing. And cross product with visualization, you can see what's happening as I change my X factor. It will work with 2 vectors. I have the X and Y. So if I take a look at visualizing my X vector and my Y vector, my cross product is going to be this one coming up in the Z. And of course, you can multiply that by adding one vector to the next one, to the next one, to the next one. That's basically what I'm doing. So cross product's an interesting tool, using 2 other vectors in other directions to gain where you want to go. Dot product has to work, at least in my view, it's going to give you a number of how far that vector is, and you're not really visualizing that, but you're taking the x vector and you're taking another one as b vector on top of it. And so if it's 2 in length for the x vector, it's going to become 3. It's going to become squaring it. So you're going to go up to 9, then you're going to go up to 16, you're going to go up to 25, and so forth as you bring up that integer. I had a reverse vector, which is basically that. You get this vector coming out here as a rotated vector, and then if I apply the reverse vector, it's just going to flip it in the actually opposite direction. So if you can kind of visualize what's happening there, we're moving from here, shooting out that way, to shooting out that way. And so it's just a way to manipulate data. And certainly that's good for reversing when you have to deal with normals and project them in certain directions. You want to gain some. And we'll finish up with these few things. I've got a point here that I actually brought in, and I think just as an anchor away from the XYZ at 0. 2 point takes that point and takes my 0 point. So I need 2 points, and I can build my vector, which will be visualized in this direction. You can visualize it out from where those 2 vectors are. And this is kind of an interesting thing. I'm going to try and angle it right. If I visualize what that vector is doing from this point to that point, and it visualizes the distance between that, it's gone from the order of the points I brought in. If I take it down here, it's going to add on to the end of that vector, because I'm actually using the vector as the anchor point, so it goes to the end of the vector. So you go to the end of this vector here, then you use that as an anchor point, you add the next one to it, and then here the vector display is going back to the 0 point. I think I shook that back to XYZ. So it's taking this point to that point, and then it's reconfiguring it to start from whatever point I wanted to anchor it. And so if I anchored it from the end of that, again, I would have this point to this point represented as a vector at the end of that vector. So try and get your head around that. I have another point here that I brought into point B, and that was just my anchor point. I should have made that clear, that point was the end point of that vector, and then that has to be oriented because of these vector displays. Vector length is going to give you exactly that, and what I did to the vector length was I came in, I took the 2 points, and I actually have a Boolean on the true vector. Let me grab this one, that I make it a unit vector, put the vector in here, and you can see I basically can have it be its full length of what it is, but unitizing it is going to bring it back to 1 in distance. So the length is going to move from what it is as a vector, 3.6, yada, 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 and into the true unitized vector. This may seem simple to end this, but there's a lot of information here in the vectors, and I've been told, and I've said it before, get to know your maths, your sets, and your vectors, and all the params, curves, surfaces, manipulations, transformations, and being able to start working things from what are the attributes of a point is going to, you'll gain incredible knowledge and be able to have completely parametric models back to the attributes of the points you're dealing with, and dealing with vectors and things like that. So, and planes and all the wonderful things that go into making up geometries. So stay with me on that. Color, a little, color, you know I like to do this to end. Make it a little baby blue, and we're done. So that's my full vector file that I'll probably put on the GitHub pretty soon, and that'll be it. And you'll have that. Now, I'm now going to go into having some fun. We're at 8 minutes. I'm going to actually go into all of the curve analysis division, but start with primitives. So I may actually start with the primitive tab, and as we build it, we're going to use the utilities and the analysis and the splines and the divisions to start to stay to building geometries that can very quickly move into surfaces through spheres and meshes and into pipes. And you'll start realizing how we can start moving 3-dimensionally. So obviously the curve is dependent upon what we learned in the math sets and vectors. So I hope you stay with it. I hope you make some creative stuff. I hope you take them to renders and it becomes useful in your life, and you can become a 3D digital modeler, sculptor, as this is the medium as much as you ever used wax, plaster, clay, or whatever. And of course, not forgetting the old. Get into it, find out what's causing you, anxiety and depression in your life, and then move on to what gives you kind of inspiration and gets the adrenaline flowing and entices you to do things and draws you in. And I find this very exciting, and to think my mind can wrap around it, it gives you ability to really expand yourself conceptually, tied to your craft and how you can direct things by math and logic. Thanks for watching. Ramble on.